Happy Friday, ladies and gentlemen. Welcome to math class. Today we are going to kind of keep class the same. Obviously, I'm out of the building right now. I can't be here. So you have a video recording in your place, in my place. So class is going to be run exactly the same. I'm going to ask the sub, whoever it may be, to pause the video whenever need be. If you guys need to catch up with notes, I'm going to be going faster than what I would normally do in a class. So you guys can pause it whenever you need. Otherwise, everything's going to be run the same. So what I want you guys to do is have the sub pause the video to go ahead, work on the warm-up question here. And when you're finished with the warm-up, go ahead and press play again, and I will be able to walk you through it. Okay, so hopefully you guys got the problem done. Let's go ahead and start working on it. So what we learned yesterday was or last class I should say, is the substitution method. And in this particular problem, we learned that the easiest variable to solve for is the standalone variable. So what I'm going to do is go through our steps again. So step one, again, remember, was to pick an equation, solve for a variable. So I'm going to pick this equation right here and solve it for c. The reason I'm doing that is because it's all by itself, and all I have to do is add 4 to the other side. So when I'm done solving it, I end up with c is equal to 4 minus 3d. So I get c is equal to 4 minus 3d. If you switch these two around, it doesn't matter. Now remember, back in step 2, what we have to do is take what we know c is equal to and plug that into c into the other equation. So it looks like 2 times that c value, which is now 4 minus 3d plus 4d equals 4. So instead of c, I've replaced that with 4 minus 3d, and I've finished writing the rest of the equation. So now I got a little bit of work to do. So I have to distribute the 2. That gives me 8. 2 times negative 3 is negative 6d, plus now 4d is equal to 4 still. Now I'm going to go ahead and combine like terms. So I got negative 6d and I got 4d there. That's going to give me 8 minus 2d equals 4. I'm going to subtract 8 from both sides. Minus 8, minus 8. So I get negative 2d is equal to negative 4. Divide by negative 2, divide by negative 2. D is equal to positive 2. Okay? Step 3, remember, was to take what we know d is equal to and now plug that back in to one of the original equations. Remember, I said in some classes that you could use this one, that one. In some classes, I even said you can use this one, and that is true. If you solve it right the first time here, it works. So we're going to say c is equal to 4 minus 3 times what we get for d, which was positive 2. And finish that off. So c is equal to 4 minus 6, and so c is equal to negative 2. The question now becomes, I have to write an ordered pair. And I don't have x's and y's, but I have c's and d's. So what I'm going to do is look and see, all right, c appears first in this one, so I'm going to say c is my x value, so negative 2 comma 2 is my answer. All right, warm-up is completed. Check your homework. As always, I'm going to scroll through and ask the sub to pause as I'm scrolling. The first question here was just like the last examples we went through in class, and also something that is not too terribly difficult. All you're asked to do is plug 8 and negative 2 in for x and y and verify if it's true. It works for both, so it is a solution. Go ahead and check your answers. Like I said, I'm going to ask the sub to pause after everything is seen. So now we're looking at questions 3. Now question 4. This one we also did in class. Remember, said boys plus girls equals a total. And if we have 4 more girls than boys, that means we take the boys, add 4, and we end up with the girls. And that was our system of equations that we solved. We end up with 256 boys and 261 girls. Next, graphs. Pause if you need to. Question 7. The sum of 2 numbers is 8. So the 2 numbers are, I don't know, so x plus y equals 8. And their difference is negative 2. So same 2 numbers subtracted now is negative 2. Those are a system of equations. You're asked to graph them so you can solve each for y, and when you do that, you find out that they intersect at 3 comma 5. So write out your answer 3 comma 5 there. Number 8, just some straight up substitution questions. Question 10 and 11, same thing, a little preliminary work. Actually, no preliminary work in each of these. And number 12, word problem. Again, please pause this. There are 16 total points for today. Please make sure that you've checked it accurately and honestly, and go ahead and hand that homework into the sub to put in the subfolder. All right, pause if you need to. We're rolling on. All right, what am I going to be able to do after today? Today I can solve systems by elimination. So this is our third method that we are going to learn. So far we know how to graph. We know how to solve by substitution. Now today we're going to learn how to use elimination. And then we're just going to apply that to some real world problems. So addition property of equality says that if A is equal to B and A plus 2 equals B plus 2, then A must be equal to B and 2 must be equal to 2. That's obvious stuff. But what we're really saying is, all right, look, I got A and B equal to each other and 2 plus 2 equal to each other. So I can take 2 and add it to both sides, or I can take A and B and add it to both sides. So this is the exact same statement, okay? So that should be B. So we must add the same thing to both sides in order to satisfy the equation. The reason it works for us here is because if I write the equations vertically, what that means is that if A is equal to B is one equation and C is equal to D in another equation, then A plus C is equal to B plus D. That's important because I can add these two and these two, and those two quantities are now equal to each other. All right. So far, this might seem like a foreign language, like why are we talking about this? Let's move into our first example and show you why it works, okay? I guarantee this method is going to be a lot easier than what we've used before. So if we were to use substitution, we would take one of these equations, maybe this one, and we'd solve it for x. And then we would take that value and plug it in for x here, and we would do 2 more steps. We are not going to do that with elimination. In elimination, we are going to add the 2 equations together, just like we talked about in the last property, so that we get a variable to cancel out. If you look, if I add them vertically, x plus x gives me 2x. Y minus y eliminates itself. It's gone. Hence the elimination method. So now I'm left with 2x is equal to, what do we got? 6,500. Okay. So now I have to divide by 2. And I get x is equal to 3,250. Okay? Much less work to find the answer for our first variable. The way we find our answer to the second variable is exactly the same way. Again, please try to keep the formatting that I'm showing you. Draw a little line in between the 2 steps. If I know that x is equal to 3,250, now I'm going to plug that in for x and say, all right, I'll use the top equation here. 3,250 plus y is now equal to 5,300. Subtract 3,250 from each side. And I get y is equal to 2,050. So again, my coordinate pair here is 3,250, comma, 2,050. So let's kind of recap what we did. All I did was say, all right, I got 2 equations. They are written in standard form, notice. I added them up so I can get the y's to cancel out. I was left with one variable. I added those 2 together to get my 2x, added these together. That left me with one variable to solve for, and the rest is the same as substitution. Okay, let's look at the next example. This is actually a word problem. Kind of the same thing. You had examples like this in the last class, in the last homework assignment, but now we're using a different method, which is actually easier. So 2 numbers. Those 2 numbers we'll call x and y. And the sum of them, so I'm adding them, is equal to 225. So there's the first equation. It says the difference, so now I'm subtracting. X minus y is equal to 147. So look, we got the same thing. I'm going to add the two equations together. X plus x is 2x. Y minus y cancels itself out. So I take 147 plus 225, and I end up with 362. Sorry, 372. Little example, a little accident there. 372. Okay, sorry. We get 372, and now I just solve for x. Divide by 2, divide by 2. We get x is equal to 186. Okay, and then the second step, I'm sorry, the third step is exactly the same as what we talked about before. I guess we don't really need to call it step 2 and 3 because there's really only 2 steps here. So we can call the second step. And now I'm going to plug in 186 for one of the x variables. So I'll pick the first equation. So I get 186 plus y is equal to 225. Subtract 186 from both sides. Y is now equal to 39. So again, 186, comma 39 is where these two, if I were to graph those two lines, they'd intersect, but now they relate to two numbers where their sum is 225 and their difference is 147. You can plug those back into the equations to check their answers if you feel like you need to do that. Okay, so first two examples, pretty straightforward. We're just adding them up. Now, take a look at this. This is not the same type of example. If I were to add up these two equations right now, notice the x's would not cancel out, nor would the y's. This is pretty close. Like if I had a -5 there, it would work, but I don't. So what we're going to do is we're going to force that to be negative. Here's how we do it. This is something that you can do. If ever you have two variables, or really the same variable x, and they have the same exact quantity, all you're going to do is multiply one of them by -1. The reason I'm picking the bottom is because now that'll take care of this -2. But if I multiply this equation all by -1, now I'll have a -5 to cancel out. Okay? So I'm going to rewrite the whole thing. So it'll be 5x plus 17y equals 1. And now it'd be -5x minus 8y equals positive 26. Now when I add up the two equations, I'll get x to cancel out. So x is gone. I got 17 plus 8y, I'm sorry, minus 8y, which gives me 9y. And now that's equal to 26 plus 1 is 27. Divide both sides by 9. Y is equal to 3. So now I'm going to go over here and do my second step because it just makes sense. Same step is exactly the same as all the others. So if I have y is equal to 3, I can plug it into either one of these equations. I'll pick the top one. So we got 5x plus 17 times 3. Actually, let's pick the other one because it's a little bit easier. We can work with this one. All right, 17 times 3. If 5x, 17 times 3 now gives us 51, equal to 1. Subtract 50 from both sides. I get 5x is equal to -50. Divide by 5, divide by 5. I get x is equal to -10. So again, my solution is -10, comma 3. And so we learned in this example that sometimes you have to multiply by -1 in order to get variables to cancel out. Okay? Next example. All right, now, these are not the same, and these are not the same. So, if I add them up right now, no variable is going to cancel out, but no problem. Notice, if I were to multiply this equation by 2, now I would have a -2 and a +2 that would cancel out. So that's what we're going to go ahead and do. So I'm going to take that bottom equation and multiply it by 2. So again, I'm going to rewrite it. So I got 4x minus 2y is equal to 16. If I multiply everything by 2, I end up with 14x plus 2y is equal to 74. All right? And now, again, I'm going to add up the two equations. So I get 28x. 14 plus 4 is 28. Y's cancel out. So 28x is equal to, what do we get? 90, right? Oh, this isn't 28, it's 18. My bad. So we get 18x is equal to 90. Divide by 18, divide by 18, x equals 5. So again, once I know that x equals 5, everything else is the same from here. I'll pick the top equation to use to plug in and solve for my y value. So I got 4 times, instead of x, now it's 5, minus 2y is equal to 16. 10 minus 2y is equal to 16. Subtract 10 from both sides, so I get negative 2y is equal to, I'm sorry, it's not 20 either, is it? Edit. So I get 4 times 5, which is 20, minus 2y is equal to 16. Subtract 20 from both sides, minus 20 minus 20, I get negative 2y is equal to negative 4, and y is now equal to 2. So my answer is 5, comma 2. That's where those two lines intersect. Okay? So in this example, we learned like you can't just multiply by negative 1, but we can by a number. So sometimes you might have to multiply by a number to get something to cancel out. All right. Now, example number 5. Again, we're solving a system. So if I look at these, those obviously don't cancel out. Those obviously don't cancel out. So what am I going to do? I can't take 5 times a number to get 2, and I can't take 2 times a number to get 5. I can't take 3 times a number to get 4, or 4 times a number to get 3. In this example, when that happens, you are going to multiply both equations. You multiply both equations, and you just have to decide which variable do you have to eliminate. What I notice is that this is positive and that is negative, which is what I need. I need opposite values, but I also need them to be equal. So in order to make them to equal, what I'm going to do is say, all right, 4 times, if I take these two and multiply together, I will get 12, right? So I'm going to get a positive 12 and a negative 12. And the way I'm going to do that is say, to get a negative 12 here, I need to multiply this equation by 4. To get a positive 12 here, I need to multiply this equation by 3. So that's exactly what I'm going to do. When I multiply both equations, and I'll scroll up a little bit and do this over here. I'll do it to the right, doesn't matter. When I multiply everything by 4, now I got negative 12m plus 8n is equal to 6. Move this out of the way here. And when I multiply everything by 3, now I got 12m. Now I got the situation I'm looking for there. Plus 15n is equal to 114. 3 times 38 gives me 114. All right, so add the equations together. M's cancel out. Now I got 23n is equal to 138. I divide by 23, divide by 23, I get n is equal to 6. So again, back to this drawing board, all of this stuff is the same from here on out. If I plug n, that is 6, back into one of these equations, I would probably pick this one just because there are no negatives. So I would say that 4m plus 5 times 6 equals 38. Well, that means 5 or 4m plus 30 is equal to 38. Subtract 30, I get 4m is equal to, sorry, it's 38. 4m is equal to 8 now. Divide by 4, divide by 4, m is equal to 2. Okay? So in this equation, in this system, we learned that we have to multiply both equations by a number. We noticed that this was opposite. We had a negative here and a positive there. So we just said, all right, let's take this one, multiply it. Let's take this one, multiply it to get both to be 12. We could have done the same thing with this. We could have said, all right, multiply by negative 2 on the bottom equation here, and multiply by 5 top equation. It would have worked as well. All right? So kind of going over the steps for doing that. Steps for multiplications to solve a system. So first of all, they have to be in standard form. if the x's and y's are not lined up, you can't add them. So first thing you want to look for is that they're in standard form, meaning x and y are on the left-hand side. Okay? Then once they're on the left-hand side, this is stuff you have to fill in. So what I'll do is I'll highlight them all. I'll give you guys a chance to copy it down. The sub can pause the video, and then we'll talk about each one. Okay, so hopefully you got them all written down now. So you're going to multiply the first equation by the coefficient of x, and the second equation d. Okay, multiply the equation by the coefficient of x, which would be d, into the second equation. And multiply the second equation, or the first equation, by the opposite of what that is. So negative a goes here. Multiplying through, multiplying through. We're going to add the two equations together to eliminate a variable, and then we're off to the races like we've seen a bunch of times. All right, so question 6. Hopefully you guys are pausing along the way to fill this in. This is the problem that that last slide addresses. Notice my x's and y's, the x's are lined up, the y's are lined up, but it's really sneaky. This is not equal to. It's not equal to. It looks like it. It's really close, but it's not. So we got to fix that. I got to put them both in standard form. I would say the easiest move to make is to add 5y to the other side. So I'm going to rewrite it as 6x plus 5y is equal now to 38. Okay? And the other equation now is 4x minus 7y equals negative 16. And so now we have the same exact problem. I can't multiply 4 by a number to get 6 or vice versa. I can't multiply 7 by a number to get 5 or vice versa. So what do? Well, I got to multiply both equations again. So if we were going to pick a variable to eliminate, again, what I notice is that these two are opposite. So I'm going to work with that. And I'm going to take this coefficient, 7, and multiply this entire equation by that 7. And take this coefficient of 5 and multiply this entire equation by 5. And when I do that, I will rewrite it again. So both equations will be over here now. What I'll end up with is 6 times 7 is 42x. 7 times 5 is 35y, and that's equal to now 7 times 38 is 266. Okay? And when I multiply everything by 5 here, I get 20x. Now it's minus 35y, got my y here. And now that's equal to, if I take 5 times negative 16, that's negative 80. So now I'm going to add. I get 62x. Y's cancel out. That's what we were looking for. Is now equal to, what do we get? 186. Divide by 62. Divide by 62. I get x is equal to 3. And you know the rest. Now that I know that x is equal to 3, I will plug that into any one of the equations. I could use this one, which I actually probably will because it's the easiest, I think. So if I plug in 3 in for x, 6 times 3 equals negative 5y plus 38. 6 times 3 is 18. That's equal to negative 5y plus 38. I subtract 18 from both sides, minus 18. And I get, I actually probably should have done the other way around. That's probably, yeah. That's a better move. I do get 18. I do get 38. But I'm going to subtract 38 instead. Hopefully you guys are thinking, what is Mr. Vespach doing? He's taught us to do the opposite of that. All right. So what we end up with is negative 20 is equal to negative 5y. Divide both sides by negative 5, and y is equal to 4. So our answer here to the system is 3, 4. Okay. So now here's the deal. Hopefully you guys paused along the way and were able to catch up with notes and everything like that. What I want you guys to do is to work on the homework assignment, solving systems of equations by elimination. This video is going to be on the Moodle page, so you can look at that at any time if you missed anything on your own. That's accessible through your device. It's just going to be on YouTube, so it's just a YouTube video you'll be able to find. Work on the homework, ask questions, work with your partners, and be productive, please. I hope you guys have a great weekend. Take care.